Welcome back, guys. We're going to take what we did yesterday with the synthetic division and we're going to apply it to something called the remainder theorem. And before I put the remainder theorem information, as you can see I have a big block of space up here, don't freak out. I'm going to explain what it means. So the remainder theorem is set up that if you take your dividend, or the first term in your division problem, divided by your divisor, you get a quotient plus the remainder, which is what we've been doing the last 2 days with long division and synthetic division. We can also rewrite that as your divisor times your quotient plus the remainder. So your dividend is f(x), the divisor is g of x, and the quotient is q of x, remainder is r of x. All this complicated stuff that just sounds very complicated, it's really not too bad. So I want to show you what I mean by that. So we're going to use synthetic division to solve this problem. We've got here x cubed plus 5x squared plus 5x minus 2. So with synthetic division, x cubed is a coefficient of 1, x squared is a coefficient of 5, x to the power of 1 is a coefficient of 5, and our constant is negative 2. We have our setup, and because this is x plus 2, we subtract 2 from both sides. This is negative 2 for our numbers. So then we synthetically divide. We drop down the 1. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 3 times negative 2 is negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 2 is positive 2. 2 plus negative 2 is 0. So previously, we would have just written this as x squared plus 3x minus 1. We're now going to we're writing it in terms of how we factored it. We know how to factor quadratics. This is just a different way of doing it, which you can actually use if you know one of the factors. We know that we divided out x plus 2. We have a remainder of 0, so our final answer today, because we are going in terms of writing it in factored form, we're just taking that x plus 2 and writing it out front. That's the only difference. So here's how the book defines it. If you're writing your notes paper pencil, I don't need you to rewrite this because this is just taking what I just summarized above. So let's try another example. We have 2x squared minus 5x plus 1. Instead of going the route of the AC method and trying to see if this is factorable, which it is not technically, which means we're going to have a remainder. So I've got 2 for the x squared, negative 5 for the x, and negative 1 for my constant. I set up my synthetic division, x minus 3, we have to add 3, which means that 3 is my number. We go ahead and we drop down the 2. 2 times 3 is 6. 6 plus 5, negative 5 is 1. 1 times 3 is 3. Negative 1 plus 3 is 2. So here's a little bit different variation. We factored out an x minus 3. What we got left was 2x plus 1, and I got that from this right here. And then because I have a remainder, then we write a remainder like we have done before. So it's a positive 2, so it's plus. We put the 2 over our original divisor of x minus 3. So we're really not truly doing anything new in this first part. The second part is to use synthetic division to evaluate the function. Simply, this just means to find f of 3. I don't want you to substitute 3 in. I want you to use your synthetic division. On the quiz and on the test, if you do not use synthetic division to evaluate it, we will take points off. So using our synthetic division, our x to the 4th coefficient is 2. We don't have an x cubed, so I put in a 0. Our x squared is negative 15. Our x is negative 10, and our constant is 5. So we got a little bit longer synthetic this time around. And it says x equals 3. We're literally going to put 3. We're not finding the opposite here because we've already done the solving to get it. So then we go through the process. 2 times 3 is 6. 0 plus 6 is 6. 6 times 3 is 18. Negative 15 plus 18 is 3. 3 times 3 is 9. Negative 10 plus 9 is negative 1. 3 times negative 1 is negative 3. 5 minus 3 is 2. So what this is saying is if I were to graph this function, that f of 3 will produce a value of 2. Now, one of the things I'm going to do is ask you to write it as an ordered pair. This simply means if my input, or x value, is 3, my output, or my y value, is 2. So what you start with and what you end with form your ordered pair. The last piece is I'm telling you that x minus 2 and x plus 3 are factors of 3x cubed plus 2x squared minus 19x plus 6. So I want to use that knowledge to factor. So I start off and I say, okay, I'm going to start with x minus 2. That means the 2 goes into the box. And then I've got 3 for x cubed, 2 for x squared, negative 19 for x, and 6 for my constant. And I go through and I drop the 3 down. 3 times 2 is 6. 6 plus 2 is 8. 8 times 2 is 16. 16 plus negative 19 is negative 3. Negative 3 times 2 is negative 6. 6 plus negative 6 is 0. When I say use it to show it's a 0 and then use it to factor, that means I'm going to get remainders of 0. So that means that so far, I have x minus 2 that I factored out, and what I had left was 3x squared plus 8x minus 3. I could go and do AC method at that point to factor that out, but instead, I'm now going to take this trinomial and I'm going to do synthetic division again. So 3, 8, negative 3, and I'm going to factor in the x plus 3, which means that a negative 3 is going to go out here. So I drop the 3 down. 3 times negative 3 is negative 9. 8 plus negative 9 is negative 1. Negative 1 times negative 3 is 3. Negative 3 plus 3 is 0. So that means I still, this is how I get my final answer. I still have the x minus 2 that I factored out originally. And then I factored out an x plus 3. And what's left over is 3x minus 1. So I just used synthetic division to factor instead of trying to go through all my factoring processes that I did in Unit 6. So now, I want you to try it. I want you to factor the polynomials. This case here, I've got x minus 3, so you're going to factor it. You're just going to do synthetic division. And then like the second type of problem we did, where you're going to evaluate the function at x equals negative 4 using synthetic division. And as always, bring your questions with you.